let's try to talk about multidimensional array. Till now we have seen single dimensional array because we were mentioning the size of only one dimension. Now the very basic example of multidimensional array is 2D array. We can actually call multidimensional array as an arrays of array. Now in the case of 2D array, it has two dimensions. We can think that data is stored in row and column wise in two-dimensional array. Here how we can declare 2D array in C and C++. So we need to mention the row size as well as the column size, or we can declare it in Java as follows. Now we could think it as a form of matrix. So here we have an array which has a name of ARR. So we can access any element using two index. So here for the element 5, the row index is 1 and the column index is 2. Now here we also can initialize the array at the time of declaration like this. You should notice one thing, that I haven't given the first dimension. I have only given the second dimension. One thing should be noted, that whenever we will be declaring and initializing the 2D or multidimensional array, we always have to specify all the dimensions except the first one. It is mandatory. Now what about three-dimensional array? Well, we can consider three-dimensional array as array of 2D arrays. Now to access or to declare any three-dimensional array, we need three index. One is the number of 2D arrays and other two are row size and the column size. So we could visualize 3D array like this, array of 2D arrays. Now what about n-dimensional array? To declare n-dimensional array, we need n sizes, that is the size of n dimensions. So in general we could give a recursive definition to the n-dimensional array, that is, it's nothing but array of n-1 dimensional arrays. Now one thing should be noted, that nothing is stored in form of 2D or n-dimensional array in the memory. Everything is stored in form of single dimensional array. Now you may be thinking, what the heck I'm talking about? You need not to worry about that, because I will be discussing it very soon.
Now let's try to talk about how we can calculate the address for the 2D arrays. Well, 2D arrays are also stored linearly in the memory. There are two possible ways we can store 2D arrays in memory. One is the row major, another is the column major system. So what about row major system? Well, in row major system, all the elements of the same rows are stored consecutively. What does it mean? So you can see that these are all the elements of the first row. So at first these will be stored consecutively, then next row's elements will be stored consecutively, and then the last row's element will be stored consecutively. But how we can find out the address of any elements? You can see that this 2D array is now converted into a single dimensional array. That's how it's stored in the memory. But how we can calculate the address of any element? Using two index. Before that, let's try to assign some addresses. Now here is the formula that how we could calculate the address of any element. I is the row index and j is the column index. So we should have to add something with the base address. Here w is nothing but the size of the data type. So we are multiplying c, that is number of columns, with the row index, and then adding with the column index. So here is an example how we could calculate the address of A22. A22 is nothing but the element of the third row and third column. That is this one, 5. So you could see that I'm adding this one with the base address, so it's giving 40. So you can also see that here the address is 40. Now if it's given like this, a in between parentheses 2 and 2, it means that we will be finding the address of the second row and second column, but it's not the index. So we need to convert these into the index, because this formula always takes index. So we will be subtracting 1 from this, you can see here that, and after that we will be getting 120, that is this.
Now what's about the column major system? So in column major system, all the items of the same columns are stored consecutively like this. Let's assign some addresses to this, and how we can calculate address of any element. So the address of aij will be base address plus w multiplied by I plus r multiplied by j. So instead of multiplying the number of columns with the row index, what we are doing here, we are just multiplying the number of rows with the column index, as simple as that. So what about the address of A22? That would be 132 in this way. And if it's given that A in between parentheses 22, then we need to subtract 1 with the row and second column, so that would be 116. That's it. So in my next video I will be discussing about dynamic memory allocation.